Today's objective is to be able to multiply and divide rational expressions. In order to do that, we need to review some previous objectives. First of all, we have to be able to put polynomials in factored form. Let's have you try your warm-up questions. Put 5x squared plus 3x minus 2 in its factored form, as well as 2x to the third minus x squared plus 14x minus 7. Enter your responses into the video, and then we'll check your results. Whenever we're factoring, we want to look to see if we have a greatest common factor to divide out, and in our first polynomial, we do not. We want to see what type of polynomial it is. It's a quadratic, and so we can follow our quadratic pattern. The leading coefficient times the constant, so what times what gives us negative 10, and what plus what gives us 3. If we think about what would work for both of those options, we can use a 5 and a negative 2. Again, we rewrite this as 4 terms, 5x squared plus 5x minus 2x minus 2. 4 terms mean we can look at them into pairs and divide out what they have in common. The first pair we can see has a 5x in common, so we can divide that out. The second pair is a negative 2 that we could divide out. Here we can see that each pair is being multiplied by x plus 1. Therefore, a factored form would be 5x minus 2 times x plus 1. Again, looking at our next polynomial, we look to see if it has any greatest common factors. It does not. It has cubic, and we see that we have 4 terms, so perhaps we can use the method that we have here when we have 4 terms, looking at into pairs and see what we can divide out. First pair we can divide out an x squared. Second pair we can divide out a 7. We can see that each pair is being multiplied by 2x minus 1. Therefore, we have x squared plus 7 times 2x minus 1. This ends up being a quadratic polynomial, and again, you have to check to see if you can factor that into more components. So here we're going to think what times what gives us 7, but adds to get 0. When we think about this, we can't use any numbers to multiply together to get 7 and add to get 0. Therefore, this polynomial is prime. Our final factored form would be 2x minus 1 times x squared plus 7. For today's lesson, we also have to be able to multiply and divide. So we've got a couple of quick reviews from previous knowledge about multiplying and dividing. Let's have you do your work on your paper and then enter your responses into the computer so we can check to see if you're on target. Five divided by 1/2. We know that dividing, especially by a fraction, to do this, we can think about it as multiplying by the reciprocal. So the reciprocal of 1/2 would be 2. So we think about this as 5 times 2. 5 times 2 is 10. Now let's think about 6 times 1/3. Again, since we're working with a fraction, we could write 6 as a fraction as 6 over 1. We know that we can multiply fractions like the previous example is going across numerators and then denominators. So we would have 6 over 3. Well, we know 6 divided by 3 is 2. So when we multiply 6 times 1/3, we have a result of 2. The reason why we wanted to review our factoring and multiplying and dividing rules are because when we're working with a rational function, rational functions are a function in the form where two polynomials are being divided. Again, the denominator cannot equal 0 in order for this to work. A rational expression is in simplified form provided its numerator and denominator have no common factors other than 1 or negative 1. When you simplify a rational expression, it usually requires 2 steps. First, you have to factor the numerator and the denominator. Then you would divide out any like terms or factors that are in common to both the numerator and denominator. So let's look at one together. we want to simplify x squared minus 4x minus 12 divided by x squared minus x. As stated in our directions, the first step is to factor the numerator and the denominator. So we want to look at factoring x squared minus 4x minus 12 and x squared minus x. Both of these are quadratics, and so we could use our quadratic patterns to help us. If I look at my first quadratic here, x squared minus x, I can see that they have an x in common, so I could divide that out, which would leave me with x times x minus 1. My quadratic here on the left, x squared minus 4x minus 12. Again, we're looking to see does it have any greatest common factors. It does not. We could use our product sum method like we've done before with factoring, leading coefficient times the constant. So what times what gives us negative 12? What plus what gives us negative 4? Here we could use our options negative 6 and 2. Again, if you're using your product sum method, at this point you're typically writing it in 4 terms, looking at it in pairs and seeing what they have in common to divide out. First pair we could divide out an x. Second pair we can divide out a 2. Here we can see each pair is being multiplied by x minus 6. So our factored form would be x minus 6 times x plus 2. Now that we factor the polynomials in our expression, we want to write them again, showing what factors are in the numerator and what factors in the denominator. So again, here's our original. These represent our numerator. Our other one, x times x minus 1, was our denominator. So we're going to write it in factored form. The second step is, once it's in factored form, to divide out any like terms from our numerator and denominator. So we're scanning to see if I've got an x minus 6 in the numerator, do I also have that quantity in the denominator to divide out? If I have an x plus 2 in my numerator, do I have that quantity in the denominator to divide out? And the same goes for the denominator. Do you have those factors in the numerators that you can divide out? In this case, we do not have any common factors, so this would be our simplified rational expression. Let's try a few more. Again, we want to write the expressions in simplified form. Again, the first step is to always make sure you can factor the numerator and the denominator. Get it down to the basic components. That way, when you perform the operations, you can see if you have any like terms that you can divide out to simplify your rational expressions. So let's take a look at number 1. So what we want to do is say, as we have everything in factored forms, if we look at our numerators, these are already in their basic components, nothing can be factored. Look at our denominators, again, they're already in basic components, they can't be factored. So we're going to perform the operations. It says we want to multiply. Again, so if we have our fractions, we multiply numerators and we multiply our denominators. So let's do that. So what I did is I wrote my like terms together that I would be multiplying for my numerators and denominators to help me think about what I'm working with. So again, I've got some like terms here. So 5 times 6, I'll have 30. I'll have a total of 5 x's, so x to the 5th. And I have a total of 3 y's, so y to the 3rd. Denominator, I've got some like terms. This will give me a 20. I'll have 1x. Here I'll have 4 y's, so that would be y to the 4th. So again, what we want to do is see if we have any like terms in the numerator and denominator that we could divide out to fully put it in simplified format. Again, so I can see I've got some coefficients here, the 30 and 20, that we could divide out. A 10 to simplify that. If I have 5x as the numerator and 1 in the denominator, I could divide 1x out. I've got some y's, 3 in the numerator and 4 in the denominator, so I could divide 3 out to help get me this in simplified form. So doing what we talked about, when everything is divided out that's alike, we'll have 3x to the 4th in our numerator and 2y in the denominator. And here's your simplified rational expression. Let's try another one. Let's try to take the expressions and write them in simplified format. First thing we want to try to do is factor our expression. So if we look at the numerator, x plus 3, we can't do anything with that. If I continue to look at our piece here of 4x squared plus 2x plus 1, it's a quadratic, no common factors. If I take my leading coefficient times my constant, I have to think about what times what gives me 4 and what plus what gives me 2. Thinking about multiplying to get 4 and adding to 2, nothing will work for that, so this is already in factored form. So I want to think about our element here in the denominator, 8x to the third minus 1. No common factors to divide out. It's a cubic function, and we know how to factor a cubic function, either with our long division or using our patterns. So on your paper, factor 8x to the third minus 1, and then resume the video. So we have our polynomial 8x third minus 1. We could break it down into the elements to use that to help get our pattern, or we could use the elements for our divisor and work on our long division. And we can see that our factors are going to be 2x minus 1 times 4x squared plus 2x plus 1. So we're going to rewrite our original polynomial using our factors here. So again, we had x to the third divided by, and then here was our cubic, and here's the factors for the cubic functions, times our other polynomial, 4x squared plus 2x plus 1. Since this is written as a fraction, I'm going to write this as a fraction as well. That's why I put it over 1. So what we want to do now, it says multiply, so we're going to multiply our fractions together. So we're going to do our numerators and our denominators. So by multiplying, here's the elements in the numerator and our denominator. What we want to do is see if there's any like terms that we could divide out from the numerator and denominator at the same time. And we can clearly see that we've got a common factor here of 4x squared plus 2x plus 1. So if we divide that out, we'll be left with our rational expression of x plus 3 divided by 2x minus 1. Let's look at our third example. Here we want to write the expressions in simplified form. We know that step 1 is always to take the polynomials and put them in factored form. Perform the operation and see if you can divide out any like factors. So let's have you try that on your paper. Put all the elements in factored form, perform the operation, divide out any like terms, and see what you're left with. Enter your response to the computer, and we'll check. So look at our expression. We can work on factoring this polynomial here, negative 4x squared plus 4x. We can factor x squared plus x minus 6, and x squared plus 2x minus 3. So to get this started, let's start with our first polynomial. Got a common factor. That would be our factored form. Here's our second polynomial. It's a quadratic. Using your pattern, we can put that into factored form, which ends up being x minus 1 times x plus 3. Our third polynomial, another quadratic, no common factors to start. If we follow our pattern, we know our factors are x minus 2 times x plus 3. So again, we go back and look at the original. We're going to rewrite all the elements in its factored form. So what we want to do now is perform the operation. So see what we have in our numerators and denominators. So we're going to multiply and see what we have to work with. At this point, you want to see if there are any common factors that you can divide out from both the numerator and the denominator. And I can see I got an element of x minus 1 in the numerator and denominator to divide out. I can do the same thing with x plus 3. I have a 4 I can divide out, as well as an x I can divide out. So if I divide out those like terms, what are we left with? A negative 1 times x minus 2, all in your numerator. So this would be your simplified expression. Let's look at example 4. Again, we're simplifying our expressions. First thing we want to look for are all the elements, so all the polynomials, are they in factored form? So this one looks like it's okay. Might have some things we can factor out here, here, and here. So let's put those terms in factored form. Looking at 3x minus 12, we've got a common factor of 3 we can divide out. Looking at our next polynomial, x squared minus 2x, I've got a common factor of x I could divide out. And our next polynomial of x squared minus 6x plus 8, it's a quadratic, so using my pattern, I can work on putting it into factored form, which would be x minus 2 times x minus 4. We're going to rewrite the polynomial using the factors that we came up with and perform the operation. So again, we're going to multiply our numerators and our denominators and look to see if they have anything in common we can divide out. Here we see we've got elements of x minus 2 we can divide out, those factors, x minus 4s. I also have an x. So if I divide out those like terms, we can see that we result in 5/3 for our final expression. Again, if you go back and look at the original, we started off with a division problem, and again, as we remember in our warm-up, when you're dividing, that's like multiplying by the reciprocal. As the reciprocal means what's in the denominator becomes the numerator, what's in the numerator becomes the denominator. And that's why we have this step here showing how we're multiplying by the reciprocal. We then took and put it in factored form, performed the operations, and simplified our expression. Example 5. Again, we want to write the expression in simplified form. So we're going to take a look at what we're given and try to take our polynomials and put them in factored form. As we're thinking about putting things in factored form, we also see that this is a division. And we know that when we're dividing by something, that's like multiplying by the reciprocal. So I probably want to rewrite that first and then start putting things in factored form. So if I'm multiplying by the reciprocal, here are the two expressions that we're working with. We want to simplify. So again, some elements we might want to look at simplifying would be our 6x squared plus 7x minus 3 and the 2x squared plus 3. Let's start with 6x squared plus 7x minus 3. It's a quadratic, no common factors, so you can follow your pattern to put it into factored form. The second polynomial we want to look at was 2x squared plus 3. It's a quadratic, missing the linear term. We can see if we can follow our pattern again and put it into factored form. Well, are there two numbers we can multiply together to get 6 and add to get 0? And if you think about what your options are for multiplying by 6, you cannot add them to get 0, so this one is prime. So we write our elements, again, our first polynomial in factored form. We're going to perform the operations. We're going to multiply the numerators and denominators to see what we're working with. Then we'll simplify by dividing out any like terms in the numerator and the denominator. So again, as I'm looking, I want exact matches for factors in numerators and denominators. Be careful. These are not an exact match. Notice how this is 2x squared plus 3, and this is just 2x plus 3. It looks like we don't have any common factors in the numerator and denominator to divide out, so this would be our simplified rational expression. 3x minus 1 times 2x plus 3 divided by 6x squared times 2x squared plus 3. Example 6. Again, writing expressions in simplified form. Again, think about your steps. We want to take our polynomials and write them in factored form, perform the operations, and divide out any like terms that we have. So we can see we've got a multiplication and a division. What we probably want to think about is, since we're dividing, that's like multiplying by the reciprocal. So you might want to rewrite that to start multiplying by the reciprocal. Since everything else is fractions, I decided to write this as a fraction as well to remind myself what's in the numerator and what's in the denominator. And so we're going to multiply by the reciprocal of this term here. So that brings us to this step here. So again, we're going to check and see are all the polynomials in factored form. X is, x plus 5 is, 3x minus 5, 1, x plus 5, 9x squared minus 25. We want to see if we can put this into factored form. It's a quadratic. We want to see if there's any like terms to divide out. There are not. So now we can follow our patterns to put it in factored form. So again, when we're writing it in two terms, in four terms I should say, we're looking at in pairs and seeing what we can divide out from each one. Here we've got a 3x in common, here we have a negative 5 in common. We can see that both terms are multiplied by 3x plus 5. Therefore, our factored form is 3x minus 5 times 3x plus 5. This is also a difference of your squares, so you could have went from here to here using your pattern for that. Since we have the factors, we're going to put them into the original expression and perform the operations. So again, we're going to multiply our numerators and our denominators. Looking at see what we have, we're going to look and determine whether or not we can divide out any like terms. So we want to see exact matches in the numerator and denominator. We've got an x plus 5 we could divide out. We also have a 3x minus 5 we can divide out. What are we left with? X divided by 3x plus 5. That's our simplified rational expression. Now it's your turn to do some more practice. Try working on numbers 7 through 12. We'll check the results tomorrow.